All right, guys, back with you here. Still talking about radicals. This time we're going to be multiplying and dividing some radical expressions. So the first three we're just going to be multiplying, right? And then 4 and 5 we are going to be dividing. But again, we're going to have to rationalize these denominators, kind of like we did a little bit before. But it's multiplying first, okay? So looking at these, again, what we're going to do is just multiply, right? You can see 2 and 3, we're going to have to use FOIL, right? First, outer, inner, last. That strategy to multiply some binomials, right? But we don't have to do that for number 1 because this is just saying the square root of 2 distributed across these two numbers, right? So if I did square root of 2 times 5, again, that is a radical times a whole number. So in that case, I would just kind of lump them together. 5 times the square root of 2, right? Kind of like if it was x times 5, it would be 5x. Same idea, okay? Now with this one, square root of 2 times the square root of 8. Remember, there's that product rule that says with radicals, if I have this, two separate radicals multiplied, that's the same, and they're the same index, right? They're both square roots. So in that case, I could rewrite it as just one radical, square root of 2 times 8, and that would be the square root of 16, right? So this would really be saying 5 square roots of 2 plus the square root of 16. And again, what's the square root of 16? That's easy to simplify, right? Because the square root of 16, that's a perfect square. So my final answer here would be 5 times the square root of 2 plus 4. Okay, that would be it, fully simplified. Okay? So pretty simple there for the first one. Second one here, okay, again, I'm going to FOIL. It's the same rules, okay? We're just going to have some radicals in here to work with, okay? So again, first, 3 times 5, 15. Outer 3 times negative, you think of this as negative 1 square roots of 7, okay? So 3 times negative 1, negative 3, and then you just put the square root of 7 after that. So first outer, inner, 5 times the square root of 7, again, just lump them together, 5 square roots of 7. And then last, this would be positive 1 square roots of 7 times negative 1 square roots of 7. Again, so that would leave me with negative 1, or just minus. And again, kind of like here, I'm going to multiply the two numbers that are in the radicals, and I can write that as just, okay, square root of 49, okay? So now I FOILed it, and I have this whole list, okay? So I have a couple things left to do. I have these two like terms in the middle that I can combine, okay, because they have the same radical, right? So let me do that first, 15, and then so I have negative 3 square roots of 7 plus 5 square roots of 7, and that leaves me with positive 2 square roots of 7, okay? And then lastly, this guy right here, right, not minus the square root of 49. Well, again, 49 is a perfect square, right? So I could say the square root of 49 is 7. So I could say minus 7. And so now I have this list, okay, and now I have two whole numbers, right, on the ends that I can combine, okay? So my final answer here, if I do 15 minus 7, I would be left with 8 plus 2 square roots of 7. So that would be the process there of foiling those. Okay, let's do one more of those, and then we'll talk about dividing. Okay, so again, FOIL. So first, 1 times 2 is 2. Outer, 1 times 4 square roots of 5. So I would do 1 times 4 is 4. Basically, anything times 1 is just itself, right? So first, outer, inner, 2 square roots of 2 times 2. Okay, so 2 square roots of 2, right? I would multiply the two whole numbers together. So 2 times 2 is 4. And then last, I have 2 square roots of 2 times 4 square roots of 5. Okay, so look, I'm going to multiply the two whole numbers together. 2 times 4 is 8. And then I'm going to multiply the radical parts together. So 2 times 5 in the radical gives me 10. Now you look at this list, okay, and you think, okay, is there anything to simplify, right? And again, before I had these two middle ones with the same radical, and I combined those, and then this was a perfect square, so I took the square root of it, okay? But here, 4 times the square root of 5 plus 4 times the square root of 2. Can't combine those, right? Because they do not have the same radical, right? So can't combine those. And then 8 times the square root of 10. Can I simplify the square root of 10? And does it have any perfect square factors? No, right? You could just say 2 times 5 is 10, and neither of those are perfect squares, okay? So really, this is it, okay? Sometimes you could simplify it down a lot, sometimes you really can't simplify it much after you multiply. So that happens for number 3. All right. So that is multiplying some radical expressions. Okay. Now looking at 4 and 5, these are going to be a little longer. Okay. So we're going to be again doing what's called rationalizing the denominator. Okay. And so what we're going to have to do for these, again, you might remember we've done this before. We have to use something called the conjugate. Again, because what the problem is with these is that there are radicals in the denominator, and I can't have that in my final answer. Okay. And so there's nothing real, there's only one thing actually that's going to cancel out the radicals perfectly on the bottom, and that's the conjugate. Okay. Again, the top can be however messy, it doesn't matter what the top looks like. It's just your only goal here is that there are no radicals left in the bottom of your answer. Okay, so how that's going to work is using this conjugate. And again, that just means the same group as what was on the bottom. So the square root of 5, but the opposite sign. So instead of minus square root of 2, it's going to be plus the square root of 2. Okay, and these are two binomial groups, so I'm going to end up multiplying these with FOIL, just like I did for 2 and 3. Okay. But again, to make this legal, I have to multiply by the same thing on the top. So 5 plus square root of 2. Okay, so let's actually do the multiplication here, right? So I'm going to distribute this 3 square roots of 2 to my top here. Okay, so that would be, again, just multiplying what's in the radicals together. So 3 square roots of 2 times the square root of 5 would give me 3 times the square root of 10. Okay. And then 3 times the square root of 2 times the square root of 2 gives me 3 square roots of 4, right? Multiplying those two radical numbers together. And again, we'll simplify that a little bit more, but let's just multiply it all together first, and then we'll simplify. Okay, so then doing FOIL across the bottom here, so square root of 5 times the square root of 5 gives me the square root of 25. Awesome. Okay, and then square root of 5 times the square root of 2 gives me positive square root of 10, right? And then negative square root of 2 times square root of 5 gives me negative square root of 10. And then negative square root of 2 times a positive square root of 2 gives me negative square root of 4. So that's what I have when I multiply it at first. Okay, now let's see what happens when we simplify. On the top, there's not a whole lot to simplify. The only thing is this square root of 4, right? Square root of 4 is the same as 2. So really, I could rewrite the top as 3 times the square root of 10 plus 3 times 2, right? Because that's what that square root of 4 turns into. And then on the bottom here, the square root of 25, again, that's a perfect square as well. I could say that's just 5, right? And then look, this is the cool part. And then look, this is the cool part. This is why we multiply by the conjugate, right? Because look, the square root of 10 positive times the square root of 10 negative, right? Combining these, they'll cancel each other out because it's square root of 10 minus square root of 10 gives you 0, right? They'll cancel each other out. And that's what we want to happen. So that's great. And then just this last thing, minus square root of 4. Again, square root of 4 is 2, right? So I could write just as 2. Okay, so all my radicals are out of the bottom. Nice, that's what we want. And then it's just a matter of reducing everything. Okay, so 3 square roots of 10 plus 3 times 2 is 6 on the top. And then on the bottom, 5 minus 2 is 3. Okay, now again, you look at this fraction, we want it to be as simplified and reduced as possible. So we can take this a step further, right? Because both the 3 on the outside here and the 6, they're both divisible by this 3. So I can divide both of these by the 3, right? That'll change to a 1. And this will change to a 2. And this will change to a 1, but again, a 1 in the denominator, we don't really need to write it. So I could say 1 square root of 10, or that's just the same as square root of 10 plus all this nasty thing simplifies all the way down to that. Okay? Very nice. Okay, so we'll do with number 5. Let me rewrite this answer. Okay, rewrote my answer up there. Let's look at number 5. Okay, so same idea. So for number 5, we want to multiply by the conjugate. Again, starting it the same way. Again, we multiply by that conjugate on the top and the bottom. Same thing, right? So it's got to be square root of 10 minus the square root of 3, right? That's what's going to cancel here. And then on the top, same idea, square root of 10 minus the square root of 3. Again, and you might be saying, oh, couldn't I like do square root of 7 minus square root of 5 is square root of 2? No, unfortunately, you can't. Again, with the adding and subtracting radicals, they have to be the same number under the radical to be able to combine them. So none of these have that. Okay, so now I do FOIL, right? I'm going to do FOIL on the top and on the bottom. Okay, so it's going to give me a big fraction here. So FOILing across the top. Square root of 7 times the square root of 10. Square root of 70. Okay, that's first. Outer, square root of 7 times the square root of 3 is negative square root of 21. Okay, square root of 5 times the square root of 10 gives me minus square root of 50. And then the square root of 5 minus the square root of 3 gives me, right, they're both negative, so I can write plus square root of 15. Okay, so that's multiplying across the top. And we'll see if we can simplify anything there. Okay, and then look in here across the bottom, again, foiling these, some of these are going to cancel out a little nicer. Okay, so I multiply here, I get square root of 10 times square root of 10 is square root of 100. Okay, square root of 10 times negative square root of 3 is negative square root of 30. Inner square root of 3 times the square root of 10 gives me positive square root of 30. And then positive square root of 3 times negative square root of 3 is negative square root of 9. All right, now it's going to be a messy answer regardless, and that's fine, that happens. Okay, so again, just simplifying. Okay, I look at the top, and what's tough here is that I have to think about all these radicals. And again, I have to consider all my perfect squares. So again, not all my perfect squares, but the first 8 of them, right? I think, okay, do any of these terms on the top, if I was to simplify any of these radicals, I would do that because they would have to have perfect square factors, right? And so I think 70. Do any of these numbers times something else equals 70? No. So this square root of 70 cannot reduce or simplify. So I move on. Square root of 21. Can I do any of these times another number to get 21? No. Keep moving. Square root of 50. Okay, I have one here, right? Square root of 50, I could break that up into the square root of 25 times the square root of 2, right? So I am going to be able to change that one, but then the last one, square root of 15, no, there doesn't have perfect square factors. So I'm only going to be able to reduce one of the radicals on the top, okay? So again, that means it's going to stay the same, except I'm going to rewrite just that third radical. So on the top, same thing. It's just going to be square root of 70 minus square root of 21 minus, and again, if I took the square root of 25, I would get just 5, right? So I would write minus 5 square roots of 2 and then plus the square root of 15. Okay, so not a whole lot changes on the top. Okay, but on the bottom, a lot's going to cancel, which is great. Again, the negative square root of 30 and positive square root of 30 cancels. Awesome. And then again, these are both perfect squares, right? So the square root of 100, is 10. And then the square root of 9 is 3. So I'd have 10 minus 3. And then my very last step is just to rewrite it. Okay, so just cramming it in here. Square root of 70 minus square root of 21 minus 5 square roots of 2 plus the square root of 15 over 10 minus 3 is 7. And again, I can't combine any of these, and I can't reduce them any further. So that is it. A pretty messy answer, but again, my one goal with all these problems, get the radicals out of the denominator, and I did that. Okay, so that is some multiplying and dividing radical expressions. Hope it made sense. Thank you for following.